Hollywood has given us plenty of examples where the protagonist will use or open a gateway to another dimension, most usually, actually always with disastrous consequences. Today, we too are going to be using gateways, but unlike a Hollywood movie, we're going to have wonderful consequences to our actions. So, if you're interested in the world of API gateways, if you've heard of this thing called Envoy, or is it Envoy? Why don't you come with me and journey into the magical world of API gateways? Well, hello, wherever you are, whenever you are, where am I? Melbourne, Australia as usual, and when is it? It's August 2020. So I hope wherever I find you and whenever I find you that you're happy, safe and well. So as I said in today's rather dramatic introduction, today we're going to be looking at API gateways, and more specifically we're going to be looking at something called Envoy, or I think as it's pronounced, Envoy, but I'm going to be saying Envoy. I'll probably jump between the two and be really annoying, but I'll probably say Envoy for the most part. So yes, if the whole idea or the whole concept of API gateways interests you, you're maybe not sure what they are, or you kind of know what they are and you think maybe you want to use them, this is the place to be. And of course, as usual, we're going to be using .NET Core APIs in this case as our route points for our API gateway. So if that sounds interesting, you're in the right place. So as usual, usual begging stuff, if you've not subscribed, think about subscribing. You'll be notified when I put new stuff up. If you do like the video, maybe give it a like. And to my Patreon supporters, thank you so much once again for your extra support. And as usual, your names are going to be coming up at the end of the video. But for now, we do have a lot to get through, so I think we better jump into it. So yes, welcome to episode 6 of season 3, where we turn our attentions to Envoy, specifically as an API gateway. So let's just go through what we're going to cover today. Now, just before we go on, I'll just say the usual housekeeping things. Code is on GitHub, so links below if you want to check out the code and look at that. There will be, or there is, an article on my blog. I'll put that below as well on this video. So if you just want to follow along using that instead of the video, you can go and check that out. And finally, the time codes for this video are below. So if you just want to jump to a specific section of the video that I'm going to go through here, you can just jump straight there rather than certain bits if you want to just see how we do a specific thing. Other than that, let's keep going. So I'm going to go through, I'm going through the introduction now, an overview of what we're going to learn. I will then take you through a bit of a demo and the architecture of what we're going to build, as well as then the ingredients and the tooling that you'll need if you want to follow along. We're then going to cover a bit of theory, which I think we need to do before we go on to the build, otherwise the concepts maybe just be a little too abstract. So we'll look at what is an API gateway, why you would use one, what the pattern looks like, what an alternative may be to it. We'll then specifically look at what Envoy is, and then we will look at how Envoy works at a fairly high level. We'll then come on to the practical build section. So in this section, we're just kind of getting ourselves ready for the main event. So in here, we set up 2 APIs, very simple APIs. I'll show you those in the demo. They're .NET Core APIs. We will build them as images, Docker images. We will configure them both for HTTPS as well, which is a little bit of work. And then we'll run both of those APIs as services within Docker Compose. Now we use Docker Compose as the main vehicle to start up all our services, including our Envoy gateway, which we do in the next section. Now just on this section, I do everything step by step as usual, but I have actually done a video on that kind of specific purple box there. So in this video, I go through it, but I don't over-explain it. If you want a deep dive on that particular bit, I've done another video that takes you through that in detail. So if some of the stuff I'm doing here doesn't make sense, maybe check out that other video and come back. But don't worry, we do it all step by step here. Then we come on to the kind of main event where we set up Envoy, and we set it up again in Docker and ultimately in Docker Compose, but we run it up with a default config. and that just routes us through to Google. But it's a good exercise because number one, it makes sure everything is running correctly, and number two, we actually use that config as a kind of baseline config anyway, and we build out from there. We add it to Docker Compose, as I've said, and then we will go into our first use case, which is HTTP routing to APIs. Second kind of high-level use cases are all around HTTPS. So in order to do that, we need to set up a certificate for Envoy, and then we will go through a HTTPS termination example with Envoy and one of our APIs, and then we will configure a cluster. Don't worry if you don't know what that means, for HTTPS, which means we have end-to-end HTTPS from Envoy through to our APIs. And then we wrap up with some final thoughts and credits. So I think now we move on to a bit of a demo. All right, so just before we go on with the demo, let's go through the architecture of what you're going to end up building today. I think that will probably help position the demo. So we'll have a client, in this case just a web browser. Then we're going to set up Envoy with listening on 3 ports. So port 9901 is, in this case, the admin port, where you can administer the gateway, pull stats out of it and all that kind of stuff. I'll show you that. And then we're going to listen on 2 other ports, 10,000 for HTTP and 10,001 for HTTPS. Now these port numbers, you can make them anything you like, as long as another service on your desktop isn't using the same port, but they can be anything. They're just what we're using today. And then you can see here that Envoy uses a configuration file, in this case called Envoy.yaml, and that's where we will do most of our Envoy work. And I'll show you that quickly, what that looks like very quickly when we take a look at the code. But as you'll have seen in terms of how we're going to step through this project, we actually spin up our 2 APIs first. They're just .NET Core APIs. We've supplied some external port mappings as they're running in Docker, so that we can access them directly from the desktop, but they also have, of course, the internal port mappings for HTTP and HTTPS. So very high level use case, client will make a request to Envoy on either 10,000 or 10,001, and again we'll step through the specific HTTPS use cases a bit later. I'm just showing you the routing example here. So request comes in, the client will form a URL in a particular way, and based on that URL pattern, Envoy will determine which API it wants to route to and pull back information for the client. So yeah, basically that's our HTTPS routing scenario. All these services are going to be running within Docker Compose. It just makes it very easy to manage, and the networking between our containers is all set up as well. Cool. So a very quick overview of the code, very quick, and a very simple demo just of that routing example. We will do the HTTPS stuff when we come to it. So here's the project you'll end up with. Let me just go over here. Actually close this down. It was running. It'll run up in a minute. So if we come back to our project overview, you'll have 3 projects. One for your Coffee API, standard .NET Core API project, Docker file to package it. Same for the T API, exactly the same, just some minor differences. And then Envoy, very simple Docker file just to build an image. And then, as I said, the Envoy.yaml file. Now you can see here it's quite verbose. There's quite a lot of stuff in it, even for our simple use cases. Don't worry, I'll take you through, not necessarily line by line, but I'll take you through the main components of it and how it works, so you'll have a good understanding. And of course, our Docker Compose file, which defines our 3 services, Envoy Gateway, Coffee API, and T API. So let's run this up, Docker Compose up. Before we do that, we'll move back over to Docker just to see we have our 3 services here. In fact, we can even get rid of these. No, let's leave them. No point in building them. We'll just spin them up again. This is just a demo at the end of the day. So we've got our 3 services up and running. Fantastic. Let's come over to browser, and let's just go direct to one of our APIs. So localhost 8081. So this is our Coffee API. We're not using Envoy at this point in time. We're just going straight to the Coffee API. And it just pulls back the name of a coffee. So long black, cappuccino, blah, blah, blah. Long black is randomized, okay? So we're going straight to the API on HTTPS. This is running within Docker, so a bit of config required there. You'll note the name of our controller. T API is obviously very similar. If I can spell it right, that would be great. It's running on a different external port. So let's just have a quick look at that, and it just pulls back different types of tea: green, peppermint, chamomile, blah, blah, blah. So where does Envoy come in? Well, Envoy comes in on a different URL, so you'll remember 10,001 for HTTPS traffic. Let's just put in a different URL form, so we're just doing /c. What will happen with that? Well, it takes us through to the Coffee API, and that's basically where the routing is coming in. So we're going to Envoy, we're providing this, I guess, prefix, and Envoy will then route on that prefix. Likewise, if you put a T in for T, you can see that similar thing happens. We go through to our T API. And we'll talk a bit more about the HTTPS termination and routing and all that stuff when we come on to that a bit later. Cool, so that's our demo. That's what you're going to end up with. Again, code is on GitHub if you want to check it out there while you're following along. But now let's take a quick look at the ingredients you'll need to follow along. Okay, let's look at the ingredients you'll need for today's video. So VS Code text editor, .NET Core SDK version 3.1, Docker with Docker Compose, Windows 10 home users. You may need to use Windows subsystem for Linux if you want to use Docker. I've put a link below on how you can set that up. A client, I'm just using a web browser, which is fine, but you can use either of those other ones as well if you like. And we're going to be creating, for the HTTPS component of this tutorial for Envoy anyway, we're going to need to use OpenSSL to create our certificates. Windows users, I'll kind of cover that when we come on to it. Linux users, you probably already have OpenSSL available anyway. But yes, you'll need to install it if you want to use it, obviously. Okay, so what is an API gateway? Let's look at two patterns, one of which is the API gateway, but to put it in context, let's look at the direct pattern. So this is not the API gateway pattern. So you can see we have 4 services, 4 APIs, all providing some kind of business logic to anybody that wants to consume it. And in the direct pattern, the client just reaches out directly to those services individually and makes the requests for whatever functionality they provide, likewise with client 2. So this is okay for smaller type applications, although it's not ideal. Definitely not good for single page applications or mobile apps, because as you can see there, it gets very chatty. There's lots of requests, multiple requests going out from the clients and multiple responses coming back, obviously, and that just doesn't lend itself well to those type of applications. And you may argue it doesn't lend itself well to any type of application, which would be a fair point. And then, of course, when you add more services into the mix, the problem gets exacerbated. And of course, you're really tying your services directly to your clients, which is typically not something you ever really want to do. Certainly not in larger systems. Again, okay for smaller applications, so I don't want to completely demonize it. But yeah, generally, probably not something you would build upon too much. So that brings us on to the API gateway pattern, and it's not that complex really. We get the same 4 services. We've now got this API gateway that sits in the middle as an intermediary or a proxy, and client requests go through the gateway. So we've only got a single request or a request to one endpoint rather than 4 endpoints. You might still have the same number of actual requests potentially, but you only are calling the one gateway, depending on how you've set it up, of course. And then the same with client 2. So it replaces multiple calls potentially, and it acts as this reverse proxy. So it kind of serves up content back to the clients as if the clients were directly requesting resources from the services. It can do lots of stuff, but we're going to be focusing on routing today. So, client makes a request to the gateway, and the gateway then determines where it goes and returns the relevant information back. So that's the main thing we're going to be doing today. But an API gateway does much more than just routing. Just to elevate what it does, you really, with an API gateway, you're trying to bring out those cross-cutting concerns. So rather than having authentication, for example, with every service, or serving up static content with every service, you want to abstract those things out, those cross-cutting concerns out, and an API gateway is a good candidate for where you would host those things that are common to all your services. And I've just listed a couple there, a few there, not everything that an API gateway can do. And in short, that's why you would use one. And I don't think, did I have it on there? Yeah, I don't have it on here, but we're going to also be doing this HTTPS termination, or TLS termination, however you want to term it. So HTTPS request to the API gateway, and then the gateway then just uses regular old HTTP, so it can do all that kind of stuff as well. Puts links to the Envoy documentation below, and it goes into all of that in a bit more detail. So wanted just to cover, you probably noticed though, you know, is the API gateway the ideal pattern? Potentially not, because you've got to be really careful with it, that it doesn't become a bloated monolith as of itself. And what's a monolith? Just as the name would sort of suggest, it's just this big massive thing that, you know, is an anti-pattern really. You know, certainly people who advocate for microservices architecture, monoliths are bad. So, you know, you've invested all this time in developing lots of lovely microservices, but then you're just routing it all through a big monolithic gateway. It kind of breaks the whole concept of why you would do that in the first place. So you have to be careful. And of course, it can also become a single point of failure, which is, again, not a good thing. And yes, kind of what I said there, it can violate the autonomy of microservices because you're kind of coupling them in to this gateway as well. So you've got to be really careful with how you use them. And again, it kind of boils down to scale. The larger your application becomes, then you have to start thinking about how you adopt the API gateway pattern. So you can solve it in a number of ways. Basically, you'll break out your API gateways, you can segregate them or break them out along different lines. So business boundaries is one concept which possibly lends itself quite well to the idea of microservices, which are all, you know, built around, you know, business contexts or bounded contexts. So that's certainly one way you can do it. Or you can do it along client types. So you have a gateway for your mobile apps, you have a gateway for your single page apps, you have a gateway for your desktop apps or whatever. And in fact, just on the next slide, I thought it was worth just bringing this up. For those of you that are not aware, Microsoft have this reference architecture for microservices called eShop on Containers, and I'll put the link below. And that's a GitHub repo, and there's also some documentation, quite a lot of documentation, and a book as well that you can download. Now, this is the overall architecture that they've kind of defined as a reference point. I don't think they're saying that this is the only way you can do something or this is the perfect way to do something, but this is just a reference point, and it's pretty good. So you can see here in the middle they are using the API gateway pattern, and they have segregated their gateways out along the lines of aligning it with their client types. So one for mobile, one for traditional web apps, which in this case is an MVC web app, and single page application. And then, yeah, they kind of proxy the request to the relevant services, microservices as required. So that's, yeah, just FYI, that's what they're doing. They originally used something called Ocelot as the gateway. Now they're using Envoy as well. So hence why, well, one of the reasons why I've chosen to do a video on it as well. So good segue into what actually is Envoy. It was created at Lyft, now with the native Computing Foundation. So they kind of look after a lot of things. I think Kubernetes is something they also look after, might be wrong. But yeah, it's got a lot of community support, and it's been more and more widely adopted. So you're probably going to hear more and more about Envoy, however you want to pronounce it, as you move through your career. So it's probably something you need to start learning about. One thing I want you to take away from today's video, I don't want you to think Envoy is an API gateway or that's all it does. It's probably more correct to say Envoy can act as an API gateway. Okay, so it's one of the hats it can wear, amongst other things. But that's the context within which we are going to be looking at it today. So it can do routing, which we're going to look at, and I've put L7 routing, which is routing basically at the URL application level, but at its core, it's a level 3 / level 4 proxy. Yeah, and as I say, we're going to be using TLS termination today in today's demo, or HTTPS termination, but it can also do things like retries, which is actually really powerful to have that built into your gateway, load balancing. You'll also see it used as, or hear it used as something called a service proxy or a sidecar proxy, where you deploy Envoy with each of your services. So it's got this kind of partner, and that means you're sort of starting to go into this realm of service meshes and all that kind of stuff, which we're not going to cover today, although I might do a video on it at some point. All right, so just finally, how does Envoy work? This is a really 50,000 foot level view of how it works. I think you'll probably understand it more when we come on to using it. So this is all done within the Envoy.yaml file that you'll remember hopefully from the kind of demo. So within that, you'll define listeners. So listeners, as the name would suggest, are just IP address, port, and we'll set up a number of listeners in today's demo. Within those listeners, you can have filters, and then each filter will have a number of routes that we can, no surprises, route requests off to. Where do those route requests go to? They go to a cluster, and then within a cluster, you'll have a number of endpoints that ultimately relate to where you want to get this stuff routed to. And an endpoint will have an address and a port. All right, so I think that's enough sort of theory, enough PowerPoint. I think it's time to get on and start building. All right, so the first thing we want to do is scaffold up our two APIs. Now, I will say I've done plenty of videos on detailed deep dives on how to write APIs, and also on packaging an API, which was the last video I did, packaging an API in Docker with HTTPS support. So I'm basically just running through that same content again. I'm not going to deep dive it, obviously, just be repeating myself. And so what I'm going through here, I'll go through it all step by step, don't worry. But if what I'm doing here doesn't make sense, maybe check out the last video that I did and then come back here. But for now, let's get on with it. So I'm moving into my working directory. I'll move into season 3. I'll move into episode 6. And I think I've got some archived stuff in there. That's all right. So the first thing we want to do is our first API. So .NET new web API, and we'll call it Coffee API for reasons that will become glaringly obvious in a minute. And then we're going to make another API, and we're going to call this, any guesses? The Tea API, coffee and tea. There we go, fantastic. All right, so let's do a listing. Okay, so let's just open this up in code. There we go. All right, so I've just basically opened our directory structure in VS Code. Fantastic. Doesn't matter that we've got this archive project in here, we're not going to be using that, but we do have our coffee and our tea projects. Fantastic. Now, let's start with our coffee. They're basically going to be exactly the same. One just is going to return a random coffee type, and the other one's going to return, can you guess, a random type of tea. That's pretty much it. It's nothing more exciting than that. So I'm just going to get rid of the weather forecast model. And I'm also going to get rid of the controller and recreate a new one. So in controllers, in the coffee API, new file, and we'll call it coffee controller.cs. Now, I do not usually like cutting and pasting code. It's something I avoid doing, but in the interests of time and the interests of moving this thing along, I am going to do that because it is very, very simple as well. Let's go through it, what I just copied in here. So I copied in the code for the coffee controller. We've got some using statements, the correct namespace. We have our coffee controller class called coffee controller, and it inherits from controller base. It's decorated with the API controller attribute, which gives us some out-of-the-box stuff that we won't really be using today, but we'll keep it in as it's good practice. And then our route is just using this dynamic route, which will be coffee at the end of the day. It just lifts the name of our controller out and uses that as the route. We then have one get action, and all that does is it takes a string and returns a random one of these strings. That's it pretty much, using this using the random function here. That's pretty much it. So if we come over to properties and look at launch settings, JSON, again, we're going to be putting these in Docker, so this doesn't really matter, but for the moment, we'll run it up locally, run it up natively. It's going to start with HTTPS on 5001 and HTTP on 5000. And if we I'll just double check that we do have, I'm going into user certificate, so run, search button, cert, open up manage user certificates. And if we come over here, I just want to double check that we have our self-signed localhost certificate for development, for a development environment, and we do. So let's save this off, very importantly. you save that, and we'll do a .NET run just to test it out. And it would help. So yes, we're just in our, I guess you'd call it solution type folder. We do need to move into coffee. My goodness. There we go. All right. .NET run again. There we go. And it should run up. Fantastic, it does. Let's open up Edge and go localhost 5001. Make sure it's HTTPS. And then we just put in the name of our controller, which is coffee, and it will get the default get. There you go, Americano, cappuccino, long black, fantastic. Just out of interest, I mean, these are the coffee names that we use here in Australia. So you go into any coffee shop in Melbourne or anywhere in Australia, this is what you'll get. I don't know if you call them the same things. So my personal favourite is a flat white. But yeah, I don't know. Comments below if those coffee names look weird to you, or you use the same ones wherever you are. All right, so that's our coffee API done. That's it done basically as far as setting up our API, and we'll be using that later. So it's Control-C to kill that. And then we just want to do a very, very similar thing with our T API. So over in here in our T API, we'll just delete this model. We don't need it. Yep, and into our controller, we'll delete our controller. And we'll create a new controller, we'll call it T controller, and it is exactly the same, except, well, I'm fairly sure you're going to know what the differences are. It's called T controller, so we'll put T in our URL when we browse to it. It's got exactly the same get action result. And then we just have some different T types here. All right, fantastic. Now the only thing I might do, just for safety purposes, I might just give these different port mappings. Let's give this 6001 and 6000, just in case we ever run them at the same time locally. I don't think we will. Let's move out of here and let's move into T. And let's do .NET run just to make sure it's working. Not the most complex API you'll ever, or useful API you'll ever see, but it'll serve our purposes for today's video. So running on HTTPS 6001 and 6000 for HTTP. If you come back over here and we just change our port number and change this to T, obviously. There we go, chamomile, and I'm sure if we refresh we'll get another one. Fantastic. Okay, so that's the basic API setup. Now what we want to do is package them up in Docker. All right, so the Docker part is actually really quite easy. Let's just kill that now, so it's not running. Let's close these down. So all we need to do for both of these is we need to introduce a Docker file. So let's make sure we have Coffee API selected. New file, Docker file. Excellent. Now, actually, as per Docker's own sort of recommendations, they recommend you actually put in this Docker ignore file, which we will do as well. Okay. And all the Docker ignore file, I will actually type it in because it's very small. It just contains two folders, obj and bin, that we just ignore. Fine. In fact, while we're at it, let's do that in T API as well. New folder, or new file, should I say, Docker ignore. Fantastic. And then we just put in the same stuff. Cool, that's that done. And while we're at it, let's put in our Docker file as well. Docker file. So this Docker file, and I'll put a link below, actually directly comes from the Docker documentation on how to Dockerize a .NET Core API or a .NET Core web app generally. It's exactly the same file. I've just lifted it and shifted it in here. And yeah, what you'll need to change, obviously, from their example is you'll need to put in, for the entry point, you'll need to put in the name of the assembly, the DLL for the respective API. So for Coffee API, that would be in bin, and you'll just see it here, Coffee API. And be careful with the capitalization, because that will come back later. when we come to use Docker Compose to run it up. So over on our T API, let's just paste it in. Now we would need to change this to T API for a DLL entry point. My goodness, what was that? T API. Okay, make sure we save everything off so everything is saved. That looks good. Now, it's in my nature to want to explain this Docker file. I really want to explain it to you, but I'm not going to. I'm going to resist. If you don't understand what Docker file's doing, go and check out my other video. I'm going to be tough on you today. All right. So we have our two Docker files now we're ready just to theoretically build these into images. I'm not going to do that yet because what we need to do next, and what I want to do next, is configure both these APIs to run with HTTPS enabled. At the moment, they are not configured to do that. So we're going to do that next. All right, so to get HTTPS working within a Docker type environment with .NET Core, we have to do a few things. First thing we need to do is create a certificate per API that matches the DLL name effectively, and that gets read in to Kestrel when the Docker container starts. And the other thing we need to do is, use user secrets to read in the certificate's password. So when we create the certificate, we give it a password, and we need to supply that password when we ingest it into Docker. So we'll do that using user secrets. Again, I'm going to go through it all step by step. I'm not going to explain it though. The other thing I will say, I think I've said it a few times, the code is on GitHub, so I'll put links below. Just if you want to obviously follow along, the code is there for you to kind of go through it in your own detail. And again, I have fully explained all this in my previous videos. So I'm going to be tough and not re-explain it in this video, okay? Because it's not the main thrust of today's video. All right, so we want to create, as I said, two new certificates, one for the coffee API and one for the tea API. And they are just effectively copies of the local development dev certificate. That's really all they are, okay? There's no real difference other than we export them as a separate file and give them their respective names. So I'm going to open up my Windows terminal. Let me kill that. Just clear the screen. Okay, so we're going to, create two certificates, one for each of our APIs, and we do that at the command line. So it's .NET dev certs HTTPS, and then we want to specify an export path, so EP. Now, as I'm using PowerShell, I need to access my user profile, so env:" user p, and then if we type tab, that fills in the rest of it for us. Fantastic. I just learned that as a new little time-saving trick from somebody on the channel, so again, thank you to you. And then the full path to where we want to store our certificate, the convention will be ASP.NET /HTTPS, and then we give it the name of the certificate that we want to give it. So in this case, we'll do our first one, coffee API .pfx. Okay, so this part here, the name should really match the capitalization of the DLL here. Okay, and then we want to specify a password. So PA55WORD. That's the password I use for everything, my bank accounts, everything. So, maybe I shouldn't be giving it away online, but never mind. I trust you guys. I don't think any of you would ever try and hack my bank account. So, cool, we'll hit enter. Now we get this message, a valid HTTPS certificate already exists because, as I said, it's really just a localhost development certificate. So it claims that it's already there, and indeed it is. That's what this dev search tool, that's all it really does. Now, just for completeness, I'm just going to do this next bit, just in case it catches us out in the future, but it shouldn't. Dev certs HTTPS -- trust. Now, we shouldn't need to do that. We've already trusted the local development certificate, and again, it says exactly that here. We'll get a pop-up if it wasn't trusted, but again, we do. And then we'll just do an up key, and we will just do exactly the same for our T API. We use the same password, highly secure password. And I will do the same thing again, just for completeness. We don't need to do that though. It's just my OCD kicking in. So where do those certificates go? Well, probably quite obvious where they go. So, or maybe not actually, if you don't know where the user profile directs to. So let's have a look at that, shall we? So if we go env user p, that's just here on my C drive users, and then lesj, which is my folder. So we go back here, C, users, lesj, ASP.NET, HTTPS, and you can see here Coffee API and TAPI, and this is the certificate from the previous video. It's still hanging around. All right, fantastic. So that's our certificates created. The next thing we need to do to actually use these certificates is create a user secret in both our applications when we come to reading in our certificate for use. So let's do that now. All right, so user secrets. So let's just close this down. Now, user secrets basically, very quickly, are a way for developers to store away sensitive information like passwords into a file called secrets.json that is protected by your file system. So nobody else can get access to it other than you or whoever is logged in as you to your machine. So it keeps development secrets secure. And it's read in via the .NET Core config API so that whatever is in there is available to your application. It's pretty much as simple as that. So the thing we need to do first is to come over to, we need to set it up in both our Coffee API and our T API. We need to come over to the CS proj file for each one, and we need to specify a user secrets ID tag within our property group. Let's just copy that and paste that, and we'll just make sure you terminate it with a backslash. Now what you need to put in here is just a unique ID, that's all. Each project has their own folder area where the user secrets or the secrets JSON file sits, so we just need to make sure there's a unique ID in there. Now I use a tool called insert GUID. Here, it's just a plugin for Visual Studio, so if you want to install it, just go, actually let me show you very quickly, go here, type insert GUID, and you can see it comes up. I've already got it installed, it's free. I only ever use it for user secrets, but you can generate GUIDs any way you like, or a unique ID any way you like, don't really mind, but it just needs to be unique to you. So to use insert GUID, I place my cursor between these two tags, hit F1, it's already selected, and then it just generates some random GUIDs for you. Fantastic. Now I'm just going to prefix this with Coffee API, just to help me distinguish it from all the other user secrets I'm using. That's pretty much it, really, as far as the CS proj file goes. So let's go back to our T API. Let's minimize that, it's saved. And come to T API, CS proj file again, user secrets ID. Secrets, I'm just making sure I wasn't doing a Forrest Gump impression. Life is like a box of chocolates, user secrets, user secrets. And then we just, yeah, I won't ever do that again, that was terrible. Insert GUID, select our GUID, and then we can just put T API in here. Fantastic, okay, so Coffee API, put our user secrets tag in, T API, we put our user secrets tag in, wonderful. Next thing we need to do for both of these is we need to actually create our user secret for both. So we're in our T API project at the moment, so doing a quick listing down here, we can see, where is it? T API CS proj, cool. So we'll create a user secret for our T API now. And the way you do that, again, is .NET user secrets set, and then it's just a key value pair. So the key will be, you'll see what that is in a second, and then the value will be whatever password you used for the T API certificate. So PASSWORD. Now, insofar as the key is concerned, the key value, we can kind of provide something in that's quite cool, and it's just it's almost like a path that Kestrel understands. And when you pass it in via, well, user secrets or any of the config sources that you have in .NET Core, it will know instinctively, not instinctively, absolutely what the value is in relation to. So you don't need to mess around with actually coding in, this is the password for our development certificate by providing in a very clear, obvious key path like this. What that happens is when the configuration API reads this in, it will pass this through to Kestrel, so Kestrel certificates development password. So it knows that this value is, as it says there, a development certificate password. And it negates the need to do all sorts of coding and setting stuff up within your program file or anything like that, which I have done previously. So it's a really nice way of kind of avoiding writing code, okay? So we're in our T API project folder, and what this user secrets command will do, it'll basically check to see that we have like a user secrets tag in the project file so that it can then create the secrets JSON file. So we'll go off and do that, fantastic. And let's just move into our coffee API, cd coffee, and we just do upkey, and do exactly the same thing. We're going to create the same user secret for our coffee API. Fantastic. So let's go and see where they are. We go in here and go into our C drive. It is in users, there's J, app data. Yeah. So just make sure you have hidden items selected, otherwise you won't see app data. Roaming, Microsoft, user secrets. And then this is what I was talking about. You know, I've got a few projects, as I'm sure you will do as well. And you know, you'll have, if you're using user secrets for all of them, if you're just using GUIDs, it will get very difficult to read. So what I've started doing is actually putting in naming conventions here. Now you can see I have one here, which I think must be for one of the test ones that I've been using, which is fine. So these are the two that I'm after here. And if you go in and we have a look and open one up, you'll see what it looks like. It's pretty simple. There you go. It's just a very simple JSON file. It's not encrypted, and we have the key, which is this nice long verbose path, effectively, to our development password. Cool. All right. So I think with that, we are now ready to package these up as Docker images and run them and make sure that we have HTTPS enabled. So let's give that a go now. All right, so now we want to basically package up both our APIs as Docker images and then run them as containers, or ultimately, as we're going to be doing, run them as services, because we're going to jump straight to using Docker Compose. I'm not going to use the Docker CLI to do this. I'm just going to jump straight into creating a Docker Compose file. You will thank me later, I can assure you. So if you're not too sure about what's the difference between using the Docker CLI to do this and using Docker Compose, then watch my last video. Docker Compose, we basically just specify, yes, our services effectively, and we'll have 3 services. We'll have both our APIs, and then we'll have our Envoy API gateway service that we'll specify in our Docker Compose file as well. But we'll come on to that a bit later. Let's just get our APIs up and running. So Docker Compose YAML, it's a YAML file. Fantastic. And then we just start writing a YAML file. Now I'll do this for the first API, I'll copy and paste it for the second one. All right, so first specify a version. I think you can pretty much give it anything you like, and then we just start specifying our services. Now the first service we're going to do is our coffee API. I suggest you give this the same name as the assembly of your API. In this case, it doesn't need to be capitalized or anything, but do give it the same name, and the same name as the certificate as well. And then we just specify a number of parameters under it. Now, the main reason we're doing this is if we want to run all these containers at the same time, but also because we want to use HTTPS within our containers, we do need a bit of config, and it's just much nicer to do it this way. So the first thing, you can either specify an image. If you're just using a static image, then you would just specify an image here, but we're going to be using our own bespoke code. So we're going to specify the location of our Docker file, because we're going to use our Compose file to build up, using our Docker file, build up our images. So specify the build path to that. And then you basically just specify where it can find the Docker file for our coffee API. So it's within the coffee API folder. // that's all you need to provide there. And then we specify some ports. And it's an array of ports. So the first port we'll specify is the external port. Can be anything, but we'll use 8080 and it maps to the internal HTTP port of our container. And then likewise for HTTPS, we'll use 8081 and it will map to 443, which is the default HTTPS port. We need to specify some environment flags. Environment. Okay, now actually I might actually copy these over because I think it's just a bit boring to watch me type. I'll take you through what they are though. So 3 environment variables. We need to tell our Docker container and ultimately our Kestrel web server that we want to listen on HTTPS and HTTP. It's kind of similar to what you would do in launch settings JSON, bit similar. So we're saying, yep, for ASP.NET Core URLs, we require HTTPS and HTTP. We want a HTTPS port to be 8081 for this container and make sure it is the same as the port you specify here. And then we're specifying our environment as development. And then we need to specify some volumes. So again, I'm going to copy that over and I'll explain them. If I type it in, I'm more than likely going to make a horrible mistake, so I'm not going to do that. So basically, what we're saying here, and this is where the user secrets and the certificate come into play. For this one here, we are saying use the app data variable. And if you want to see what that is, it's just in PowerShell env app data. That's just C users, there's J app data roaming, then Microsoft user secrets. So find our user secrets file there for our coffee API. And again, that's where this comes into play and is important. And then we just copy it to a location within the container. And then likewise for the actual certificate itself, it uses the user profile and it finds our certificate for our coffee API. And I've just noticed I've spelled that wrong, so that would have not worked. There we go, cool. And that's basically it. So that should work. So if we save that and we make sure that we are in the right folder, do a listing. So we're in the Docker Compose, we can see Docker Compose, and we do Docker Compose up, and we specify the build flag. That will go away and it will build our coffee API image for us and run it up using Docker Compose. So let's cross our fingers. Now, it might take a while actually. If we pop over here, yes, it will take a while. So it's going into our Docker file, and let me show you the Docker file. It gives me an opportunity to explain it to you because I feel a bit rotten that I didn't do that. So yeah, basically it's going away and it's stepping through this Docker file for our coffee API, and it's pulling down this first image. Let's move back over here so you can see what's happening. It's pulling down the SDK image because I don't have any locally, and then it's just going to step through the rest of the steps, which is basically to perform a restore on our project file, and then it's going to do a .NET publish to kind of build the whole thing using the SDK. Then because we don't want to have a runtime that has all the SDK stuff in it, we pull down a second image and do this multi-part build where we use the runtime image to produce a runtime image that's a lot leaner and smaller. So you can see here it's pulled down that image. It's now here, available for us to use. So if we run this again, and we will do it again, it'll be much quicker. We're not pulling down these images. Now obviously it will do a check at some point in time to make sure that the image is not out of date or whatever. So it's running through here, and then it's probably going to run down, and it's going to, step 7 I presume is, it's pulling down this runtime image, coming down quite quick. So yeah, let's just let that finish. And then obviously finally we specify this entry point so that Docker knows what to start when we start the container running. So we have our 2 base images pulled down and cached for future use. And yeah, there you go. So it's just started up our coffee API. It's running it as a container. It's kind of given it its own name. We have an image now as well that we've just built. And you can see down here that we are listening on port 443 and port 80 on any IP address. So what that means, if we go over here, and this was, if you remember, this was our previous local running example. We're now running in Docker. What we need to specify is, if we come back over to here, we need to specify either one of these ports. These are the external ports that we can access from our desktop. These ports here, 80 and 443, are internal to the Docker container. So let's try 8080 and see what happens. And we'll need to make sure we change this to coffee. Connection is not secure, maybe because we still get HTTPS, so let's take that out. Fantastic. Give that a go. That's better. So what's happened is it's redirected. So if we come back over to our code, you'll probably remember that HTTPS redirection is on by default. So what's happened there is we've attempted to use the HTTP port. It's been successful, but we've then redirected to HTTPS on 443. And you can see here, we're using port 8081 and everything's secure and everything's working well. And we can just refresh that. Just to allay your fears, or just to double check, if we did, oh, I don't know what I did there. If we put in, not 80, if we put in 443, for example, we'll just get an error. That port is not available to us. It's only available internally. And you'll see how that manifests later when we come on to using the Envoy gateway or the Envoy gateway. Cool. All right. So that's excellent. So we Control C, that will bring down. It should bring down, there you go, brings down our coffee API, it stops it. So all we need to do then, really, is do a bit of a cut and paste. I'm sure you don't mind now that you've seen how it works. We'll have to make some minor adjustments to get it all working, but we will copy it from here. And then we will, and this is where you've got to be really careful with YAML files. You've got to make sure that you got everything lined up correctly. So we've got service 1 is basically coffee API with our credentials. We're now specifying our T API service. Now we just need to make sure that we update these things as appropriate. Now these ports will stay exactly the same. The internal ports are internal, so they don't change, but we can change these. So we'll change this to 8082 and 8083. So 8082 for regular old HTTP and 8083 for HTTPS, and make sure you update that one as well. And I think everything is the same. Now again, these don't change because we know we've got the tag, the user secrets tag in our project file, so it can find this stuff without having to do any other config. Wonderful, I think that looks okay. So let's save that off, and then all we'll do again, we'll do another Docker Compose build, because we want to build our T API. Now this should be really quick because we've already got our base images, so it doesn't need to pull them down. Let's go away. It's building coffee API, cool. And that's really quick. Now it's building T API, and it should be equally as quick, to be honest with you. And unless we've made some horrible mistake, there we go. So they're both up and running. T API is up and running, Coffee API is up and running. And you can see here, you know, nicely color-coded differently. Ports are exactly the same, 443, 443, 80, but the external ports are different. So let's just pop over here and let's change the controller name to T. Let's change it to regular old HTTP. And what was it, 8082? 8082. And that should redirect us, and indeed it does, to HTTPS, port 8083, and we've got English breakfast, chamomile, peppermint, English breakfast. I'm trying to get, oh my goodness, did I put, there we go, Earl Grey, that's what I'm drinking right now. So cheers, I'm going to have a little drink of tea, rest my throat, I'm going to come back and I'm going to take you through the more exciting stuff, which is Envoy. Okay, so back over on our project, I'm just going to do a Control-C to kill our running containers. I'll do it, clear the screen. Now, just one thing I think I neglected to mention when I created the Docker Compose file, and I'm probably stating the obvious, but I just wanted to clarify, yes, the Docker Compose file should sit above the T and Coffee APIs. It's at the kind of root of our solution. So just wanted to call that out. I don't think I made that clear. So yeah, that's point number one. Point number two is we're going to come on to configuring up Envoy now, and the vast majority of that's going to be done within the Envoy.yaml file. Now, viewers of my channel, or people who have never been here before, what I usually like to do is type stuff out. I don't like cutting and pasting. However, rules are there to be broken. And in this instance, given the nature of YAML files generally, and the fact that they can be quite particular about whitespace, and also the length of these YAML files, they get quite verbose, to be honest with you. For me to type it out, you don't want to watch me do that. Even if I sped it up and put music over it, you do not want to watch me do that. So I felt I'll copy and paste it, but I will explain it as we go. Now, if I make any minor tweaks or changes, then I'll of course type that in, but generally speaking, as a baseline, I'm going to be cutting and pasting stuff. So hopefully that's my explaining it afterwards is a suitable compromise. Okay, so the first thing we want to do is create a new folder called Envoy for our Envoy config. And the first thing we need to do inside that is create a Docker file. So we're just going to do this step by step. I'm not going to use Docker Compose just yet. Park Docker Compose for a minute. We're just going to use Docker file, stand up our Envoy gateway with a default config and make sure it all works. Okay, and then we'll fold it into Docker Compose. And then I'm going to fall off my seat here. Then we're going to actually do our config that will route to our APIs. Okay, so just layering up bit by bit. So the first step, Docker file. And I'm actually going to start my cutting and pasting endeavors. I'm just going to copy this over. I could probably type this out, but again, probably simpler to do it this way. So we're just specifying the build image. In this case, it's Envoy from Envoy proxy. And I've specified a version here because, well, I've designed this tutorial around this particular version. So unlike with the Docker files for our APIs, we're not building from source code, we're just pulling down an image. And we can adapt this as we need to when we move over to Docker Compose. Now, the only other thing we need to do in our Docker file is copy the Envoy.yaml file, which does not exist yet, but will in a second, over to our image when we build it up. So we're going to do a Docker build our Envoy image with this config is basically what we're going to do next. All right, so copy Envoy.yaml, which we'll put in here as well, and we'll copy it over to this location. Cool, so save that off, and then we'll create our Envoy YAML file here. I probably should put a counter on screen every time I say Envoy.yaml, because I'm going to say it quite a few times, I've got a feeling, through the course of this tutorial. So be prepared, Envoy.yaml is going to be mentioned quite a lot. Okay, make sure I've named it right. Okay, perfect. So where we're going to get our Envoy.yaml file from is if we move over to the Envoy or Envoy documentation, they have of course have a getting started section, and here they have a quick start. And here they say we have a very minimal, note those words, very minimal Envoy configuration that can be used to validate basic plain HTTP proxying, which is perfect for what we want. So I'll open that in a new tab, and that's just in GitHub, and I'm just going to copy this. And I think it's 55 or so, like 55 lines, there you go. I'm sure you would not want to see me type that in. I certainly don't want to type it in, so even if you did want to see me do it, I'm not going to. So we'll save that off. Now, before we build our image, I'm just going to change this IP address to any IP address, 000. I'm not going to go through all of this, but before we build it, I'll take you through a couple of things. But before that, maybe we take a quick look at, just to refresh how Envoy works. You'll start with a listener. A listener will have a filter, and then filters have routes or routes, depending on what part of the world you live in. And then those routes basically map down to a cluster, and the clusters can have multiple endpoints, basically it. So up here we have our first listener, but it's really a special case listener. It's an admin interface on port 9901, excuse me. And I'll show you that when we run it up. And then we have our actual proper listeners, which are listed as static resources. You can have dynamic resources, which we're not going to cover today, which are basically this config is built dynamically. We're just specifying it in a very simple static way. And we have, at this point in time, one listener listening on any IP address on port 10,000. Okay, and then we'll come on to what it's doing below in a minute. But let's, for now, make sure everything is saved. Let's move into our Envoy folder. And let me bring up this Docker plugin. So you can see here we do not have a Envoy image here. So quick directory listing, make sure we can see our Docker file and do a Docker build, and then we'll tag it, we'll give it a name, Envoy Gateway, and don't forget your build context. So we're going to do a build using this Docker file. It's going to pull this image down, move our config into the image, and we'll then run it up when that's done. Okay, so that was super quick actually. Anyway, so you can see here that we have our base build image, Envoy from Envoy proxy, and then our actual image, our Envoy gateway, which includes our config. Fantastic. So coming back to the Envoy.yaml file, we're going to run this up just using the Docker CLI. We have 2 ports that we want to expose, basically. So let's do clear the screen, and we'll do a Docker run. Specify our first port. Now we're just going to use the same external port to internal port mapping, so 9901 to 9901, and then we'll do one likewise for port 10,000, which is our main HTTP listener, and then we just specify the name of our image in Envoy Gateway. Goodness, is that right? I think that's right. Okay, we'll find out if it's not. Okay, so it's run up our Envoy Gateway. It's got the little green triangle now. Just a couple of observations. If you've done anything wrong in your YAML file, and I have frequently done lots of stuff wrong in my Envoy YAML file, what you'll probably find is that the container will run up and then it will just crash, and it will just be, you won't see it running, it will be stopped. Okay, so that's a surefire sign you've done something wrong. The other thing I've noticed is, which is kind of a bit counterintuitive, the more verbose you kind of have, the more verbose messaging you kind of have here, the healthier it is. I've found out whenever the other situation I've had is I've run up the gateway, it stays running, and I'm thinking, oh, it's all cool, it's all working really well, but it's not, there's something wrong. That tends to manifest by a reduced amount of output that you can see here. So just a couple of tips. They're just my observations. You might have a different experience, but just a couple of tips for you. So check that it's running. If it's not running, you get an error. If it is running, just have a quick look at the verbosity of the output. And if it's really only got a few lines of output when it runs up, it's probably something not quite right. Okay, so let's take a quick look at what we've got. So we will move over and go to localhost, and we will look at our admin interface, which I'm not going to do too much with today, but it's a good test to make sure everything's up and running. And you can just look at your clusters, which we'll come on to in a bit, your listeners, which is one listener there, cool. And then you can do other really cool stuff like export your stats, which is basically just a lot of data into a tool called Prometheus, which is like a data aggregation tool, and have dashboards, and it gets really pretty cool actually. So I'll put a link to a really good video a guy did on taking stats out into Prometheus. It's really good. So that's just our admin interface. Now coming back to our YAML file, we had one main listener, which, you know, this is pretty obvious stuff. Listening in any address, listening on port 10,000. There's quite a lot of fluff here, but ultimately, coming back to our diagram, it's all necessary fluff, I hasten to add. We define a filter, and then we define a route within the filter, or multiple routes. So here, and you can have multiple filters as well, obviously. So you have a filter chain, which can have multiple filters. We only have one at this stage. You give it a name. It needs a type. The type is basically just specifying what type of traffic it should be looking for. Talking about stats, here's something called a stat prefix. So when you export stats out, it will be prefixed in this instance with something called ingress HTTP, which you can use to report on, all that kind of stuff. And then we have our routing config, and then you can name, excuse me, or have a number of routes. So you create this virtual hosts tag, which is basically the kind of key central aspect to specifying a number of routes. Just give it a name. I don't think that does anything in particular, and then you can specify the domains to filter on. This stuff it just blows up, to be honest with you, and you can do loads of stuff with it. So this is really basic. This is just kind of looking for all domains, and then we specify one route. So we're just going to match anything, basically. And we will come in, when we come to routing to our APIs, we'll change this to look for specific patterns, and we will route off to our respective APIs. So this is the stuff we're going to change. But for this one, this is just the default, simple stuff, and then ultimately the route that's being specified. We're matching anything. We're going to do a rewrite to google.com, and then we map to this, or route to this cluster. So coming back here, you can see here, it's really the route that maps, maybe we bring this up. It's the route that really maps to the cluster, and then the cluster has a number of endpoints that have an address and a port. So if we come back over here, this is our route, and it's mapping to this cluster down here. So again, here's our cluster definition, and ultimately it jumps down to this cluster name here, Service Google. So you can see here, Service Google maps to Service Google. So it comes down here. There's a whole hierarchy of endpoint definitions, and this is where you can do load balancing and stuff like that. We're not going to do that today. But ultimately, you end up down at an address, then you specify where you want to route through to, and we're going to route through to google.com on port 443, which, as you are probably aware, is the HTTPS default port. If we're using HTTPS, then you have to specify this transport socket, which is TLS effectively. Cool, so that's at a very high level what everything is doing there. We'll go through it in a bit more detail when we come to doing our own config, but let's test it out. So what we should see is we're listening on any IP address. We're listening on port 10,000. We are looking for basically any prefix, and then we're going to route to Google. So let's come back over here. Let's go to port 10,000 and hit enter. There you go. So just routes off to Google. So not hugely impressive. However, it is working. Fantastic. So the next thing we're going to do is we're now going to fold this default config into our Docker Compose. So we can do a Docker Compose up and everything will come up together. And then the main part of the tutorial is going to be then going back into Envoy.yaml and editing it and updating it so that we can start to route to our APIs. Okay, so we want to move what we've done by and large from Docker, a Docker file, into Docker Compose, basically so that when we can start everything up together, and we also get the benefits of the networking that comes with Docker Compose. So let's just close down or kill our gateway by doing a right-click stop. Now, if you're not using this plugin, which I would really suggest you do use, then if you just do a Docker PS, that will list your running containers, and then just do a Docker stop and copy the container ID. Okay, if you're not using this plugin, but I highly recommend it. Okay, so we want to move back over to our Docker Compose file, and we want to just essentially add a new service into here, which will be our Envoy gateway. So I'm going to move it to the top just because revisiting our, I guess you'd call it architecture, it's kind of at the front end, so it doesn't really matter where you put it, to be honest with you. It's just more my OCD kicking in. So we'll give it a name, service name, Envoy gateway. Seems like a good option. And like we did with the APIs, we can specify a build location for the Docker file. Now, what you could do instead of specifying a Docker file is you could just specify the Envoy image in here, and we could pretty much do away with the Docker file altogether. But I'm going to keep the Docker file just in case I ever need to move back to it and I want to use it in isolation. So I'm going to do it that way anyhow. But you could, if you wanted, just specify the image in here. But we're going to, as I say, go with this approach. So Envoy / will take us into here, and we'll use the Docker file. Fantastic. Next, we want to specify our ports that we want to be using. So ports. Now, it kind of follows a very similar pattern to what we have done here. And we'll just specify 9901 to 9901. And we'll specify 10,000 to 10,000. And then finally, we'll specify volumes. And this is where we will read in our Envoy.yaml file. Now what I'm going to do is I'm just going to copy from some config I have over here. Okay, I'll just rename that as Envoy. There we go. So basically, we're going to copy from Envoy.yaml ding, and copy across to here. Now what we can do is we can just comment this out with a pound sign. So all our Docker file contains is the name of the image that we want. And we'll say we could move that into here if you want. And if you want to do that, feel free. I'm just leaving my Docker file there. All right, so I think that's all we need to do to move it into Docker Compose. Let's run it up and we'll see how we get on. So I'm going to move over here. I'm going to kill all these. And we're going to do a Docker, actually clear the screen just to make it nice and clear. Docker, actually we need to come out into the Docker Compose file. So make sure, yep, you're in the correct folder, but you can see your Docker Compose file, and it's Docker Compose up. I'm going to specify the build flag. And you can see it's actually going away and building our Envoy gateway, because even though we built it at the command line using Docker, when we're using Docker Compose, it will build it in its own image, as its own image. There we go. So let's see what we've got. So we've got all three things up and running. And you can see here, this is what I really like about Docker Compose. It will color code the things differently. You can see here we've got quite a lot of verbose output. There really should be no difference. We're just running it in Docker Compose, that's all. And all three of our services are now up and running and potentially networked together, which is good. So let's just check that that is indeed the case. And it's still working. Let's just check our admin port. That's all working. Cool, so we're in Docker Compose now. Now we're going to move on to going back to the YAML file, and we're going to start routing to our APIs. All right, so now we're going to come on to the main part of today's tutorial, which is to deep dive into the Envoy.yaml file and make some changes and do some routing and do some other bits and pieces as well. So first off, let me just kill these running containers for the moment. Now, yeah, just sort of stepping back, I think for the most part, we're going to just be really concentrating in the Envoy.yaml file. We'll make a couple of additional, in fact, just one additional change to the Docker Compose file when we come on to working with HTTPS, but for now, we're really just in the Envoy.yaml file. So let's start with what we're going to look at, which is routing to our APIs. So we'll end up with a client, which will just be a web browser. We have Envoy, we have our two APIs, we've got all that. But what we're going to add now is when a client makes a request to Envoy, we're going to route off to the correct API. Now we're going to do that based on like a URL pattern. So the client still needs to know that it needs the coffee API, of course, in this instance, and it will form a URL as such. And then Envoy will intercept that URL, look at the pattern, and then go, this is the coffee API, or this one needs to go to the tea API, so on and so forth. So that's what we're going to do now, and we're going to work within the YAML file. So let's set up our coffee API first, routing to our coffee API first, and we're just going to be using plain old HTTP. The last few videos I've done have been on HTTPS, so I'm so used to saying HTTPS, but we're just doing plain old HTTP. All right. So we're really going to repurpose most of the config that we already have. Now we're going to come down and just look at our listener. So this is not going to change. We're still going to listen on port 10,000 on any IP address. We're still going to be using HTTP, and that's all fine. So really where we're going to make our changes is to this route here, okay? Or this is our collection of routes, and we're going to make a change to this particular matching section here. So rather than just looking at any prefix, we're going to look for anything that starts with, you can put anything you like here obviously, but for our purposes we're going to use a short code of C for coffee. So anytime we get a request in on any domain with a /C, So we're not going to do a host rewrite, we are going to do a prefix rewrite. And what we're going to do is we're going to rewrite it with the name of our actual controller, which in this case is coffee. Okay, so anytime we get a C, find a /C, we're going to do a rewrite or a prefix to coffee, and we're going to direct off to our, and we'll call this our service coffee. Really should be coffee service, shouldn't it? I prefer that, okay? And we'll have to change that down below. So just coming back to how Envoy works, just to refresh you one more time. We're not changing our listener in this case, and that port is 10,000 in our instance. We're not really changing our filters as such. We are changing the routing attributes, and we will need to come down to our cluster next and make the necessary changes down there. Let me just change this to 10,000 just to come back. It just makes it more consistent. So the first thing we want to do is update the name of our cluster. So if we come down here, it was called Service Google. I'm going to copy it and rename it Coffee Service, and here as well. Okay, and it's actually this name here that it actually looks for and actually matches on. Now, just before we come down to that, you can see here at the cluster level, there are some other things you can set, such as connection timeouts. You can set retries. You can see here that there's a load balancing policy as well. So we could have two instances of our coffee API running, and Envoy will load balance between them, all that stuff. But we're just doing fairly simple, straightforward routing. So when we come down here, this is the main thing, the address that we want to update. Taking a quick step back, this is where Docker Compose is really useful, but this is where you have to know a little bit about Docker Compose networking. So we've set up our Coffee API service here, and we've mapped these external ports to these internal ports. Now, the external port mappings are there purely for me and for you to go in from your desktop and make sure the Coffee API is working. From a Docker Compose perspective, all these containers are now networked together, but the port that they have access to is not this external port. The port they actually have access to are these internal ports. So when we come over to our Envoy.yaml, because the Envoy proxy is running in a container and it wants to talk to our API container, the port that we specify here for HTTP is port 80. Okay, now that caught me out. And if you, I've not done a lot of Docker Compose stuff or a lot of Docker stuff, the networking stuff will trip you up. And just as an FYI, if anything is going to trip you up, if anything is not going to work here, it's going to be down here more than likely. It's going to be with the endpoint networking. Now, the only other thing we then need to update is this address. So we're not wanting to route to Google, we're wanting to route to our Coffee API. So what do we put here? If you want to put localhost, you can try and do that, but that will not work. So I actually ran into that issue when I was testing this and developing this particular video. I had my APIs running natively. I didn't have them running in containers, and I used localhost, and the thing didn't work. It doesn't like localhost, and that's why I ended up making another video about custom domains and stuff like that. Anyway, another lovely advantage of Docker Compose is that we don't need to worry about that. We can just simply use the service name. And because all these containers are running within Docker Compose, anytime a container references service name, Docker Compose does some nice translation for us and translates it into an IP address. So, that's not what we want. We want to put in Coffee API. Okay. Fantastic. Now, the only other thing we want to take out for now is this, the transport socket, because this is not running over HTTPS, it's just HTTP. And you will get an error if you leave that in, and that's another bit of a gotcha. I've left that in before, and it won't route. Go figure. Makes sense though, really. So I'm going to take this out as well, because we don't want to keep that there. Fantastic. So let's just refresh what we've done. We've kept our listener the same on port 10,000. We've kept most of our filtering stuff the same. But when we've come down to our routes and matching for patterns, we have updated that. So we're going to look for anything with a prefix of C, and we're going to route it to our coffee service. But before we do that, we're going to rewrite the prefix to what we actually want, and then we're going to route it to this endpoint. And because we're running in Docker Compose, we can simply specify the service name. Now, the beautiful thing now with Docker Compose is we simply do a Docker Compose up and build, just to rebuild everything. And we'll test it to see if it works. So again, if you get any errors, the chances are it's going to be down at this point here. Okay, so how are we going? Everything is green. Let's see how we're going to go on. So let's go back over here. Now we want to go, yes, to our Envoy gateway, but this time we want to provide /c, and it should, hopefully, there we go over to our endpoint, and it's serving us up an Americano. Very nice. I could do with one of those right now. Now you can see what's actually happened though, because we've still got HTTPS redirection within our API. It has redirected, and you can actually see the actual address of our API. It's kind of rerouted. Now when we introduce HTTPS into Envoy, that won't happen. So we'll come back and we'll deal with that in a bit. So that's our first bit of routing done. So we're now going to embolden ourselves, and we're going to add in our T API, again, just using HTTPS, not HTTPS, HTTP. And then the final part of the video, we'll explore HTTPS a little bit as well. So kill that for the moment, and we'll come back up here. Now again, we're just going to listen on our port 10,000, and all we're really going to do is add some new stuff in here. So as you can probably tell, it's this stuff here that we just need to duplicate. So again, with YAML, anything with a dash is kind of like a multiple array type item. So we can have multiple routes or routes. So let's just copy this. And this is where you've got to be really, really, really careful with your indentation. And this time we're just going to put T, and here we're just going to put T. And then here we're going to change that to T. Now we obviously don't have a T cluster. We need to add that in. So again, you just sort of build this up, you layer this up, and it becomes quite straightforward. So I'm just going to basically copy all of this. Again, you can see that we have an array element here. So we're just going to copy this, and by and large we can copy it down. You just have to rename these things here. I do appreciate I could do a find and replace, but I'm missing typing. I don't like cutting and pasting. And then let's just jump over to our Docker Compose to make sure we have the right name. Yep, T API. Cool. Let's copy that, and we'll put that in here. And again, same internal port. We were using port 80 internally. Well, we weren't. Docker's using port 80 internally with our T API, so that's fine, same port. So save that off, and let's run that up, see what we get. Everything's running. Now, I do appreciate that we're only changing this YAML file. We don't really need to rebuild the other containers, but it's so quick that, it just saves us some hassle. So let's go, we have to change this a little bit. Let's go back to HTTP, because we're going on that at the moment. Localhost 10,000, and let's try /t. And there we go. We're getting routed through to our T API, and it's doing the same thing. It's redirecting us to HTTPS. Now, because our Envoy gateway isn't dealing with HTTPS at the moment, we just get a plain reroute, which is okay. Fantastic. Okay, so that's very simple routing, and you can see how you could potentially build that out to become more complicated, but for now that's what we're going to do with routing. And then the final thing we're going to come on to do is actually configure the Envoy gateway to use a local certificate, so it can deal with HTTPS termination and all that kind of stuff. So we'll do that next. All right, so we're going to move on to looking at HTTPS a little bit now. Now what I'm going to do is I'm just going to show you last PowerPoint of the day. I'm sure you'll be pleased to find out. But actually, do you know what? I like to visualize stuff, so I find diagrams are quite useful when trying to explain stuff. So what we're going to do now is we're going to have our client, and we're going to configure Envoy for HTTPS, which we've not been doing as yet. We've just been going with a HTTP request. So what we're going to do is we're going to configure our 10,001 endpoint or listener with an Envoy to basically be our HTTPS endpoint for Envoy. Now, as part of that, we'll need to set up a self-signed development certificate for Envoy, and we'll put that into the Envoy.yaml file. And then the two scenarios we're going to have, our poor old API, we're going to disable HTTPS redirect. Still going to have a HTTPS endpoint. We're just going to turn off the redirection stuff. And then what we're going to do is we'll just get Envoy to route to it on HTTP. So this, what you can kind of see on screen here, this kind of idea is called TLS termination or HTTPS termination. Now the idea is that your Envoy gateway is kind of public facing, and so public clients should be using HTTPS, but once you get to your kind of internal domain, then it's okay to use just plain old HTTP to talk to your backend services. Now, you'll see that used. Personally, I don't like that. I feel everything now. I'm an advocate. I'm a convert. I think everything should be HTTPS. Yes, there's a little bit more overhead involved, but I don't like that. But I'm showing you anyway because it's definitely a config that you'll see, and people will advocate for this setup, and that's fine. There are advantages to it, but for me, I don't like it. But nonetheless, you'll see it. And then we're going to retain our good old coffee API is going to stay with HTTPS redirection turned on, and we're going to then actually create a new cluster that will use HTTPS to Coffee API. So client will talk HTTPS to Envoy, and Envoy will talk HTTPS to Coffee API, which is thumbs up from me, my preferred approach. But you will also see the other approach, the first approach that I've shown you. So the first thing we'll do is we'll turn off HTTPS redirection in the T API. We'll then create our certificate for Envoy, and we'll add that into Envoy, and then we'll add our new cluster to Envoy as well, so that we can talk to the Coffee API. So I think with that, we'll get started. All right, so let me just take this down. Let me just kill that off to stop our running containers. And yes, the next thing we want to do is we want to basically turn off HTTPS redirection on our T API. So we're coming over here, open up T API into startup, and then just comment this out. Now we still have a HTTPS endpoint, obviously. We're not taking that out altogether, but we're just not redirecting when we make a HTTP call. Excuse me. All right, so that's saved off. I did lie when I said we weren't updating any other code. Hopefully you can forgive me though, but I think that will be it for now, but don't hold me to that. So let's close that down. Now the next thing we need to do is create a certificate for Envoy to use, because coming back to, well, yeah, we just went through it, but coming back we need a certificate in order that it can talk HTTPS. Now unfortunately, it's not as simple as doing .NET Dev certs like we did for the APIs. We need to use a tool called OpenSSL, which is, I suppose, a Linux-based tool for, amongst other things, creating self-signed certificates. So we need to make use of that. So for the Windows users out there, you've got a couple of options. If you have Git bash installed, which will more than likely be installed when you installed Git, and if you accepted the install defaults, you will have OpenSSL installed. So you can use that, or of course you can just Google it and download the binary, or as I'm going to do, I'm going to use my version of Ubuntu running on Windows, which is running on this WSL system, Windows subsystem for Linux, which is rather nice. So I'm going to use that, and I have OpenSSL available to me from here. So the first thing I'm going to do is open an Explorer window, which is quite cool. So Explorer exe dot will open up Windows Explorer, and it will take you to this network location where it gives you access to the Linux file system, which is really, really nice. So let's just minimize that for a minute. No, we won't. We'll actually, we'll re-maximize it, because the first thing I need to do by way of creating a certificate is to create a bit of a config file, which tells OpenSSL how we want to create our certificate. So new text document, and we'll just call it HTTPS dot, we'll call it config. Okay, we'll probably get a warning, we do. Let's just open that in VS Code. So again, it's really quite cool. You can open files from this Linux subsystem in code. Now, no surprises, when you see this, I'm just going to cut and paste it in. So again, the code is on GitHub. I'll make sure I put this up here as well. And you can just use this. Now, what you can see here is this was another project I was working on, so we'll change that to localhost. And we'll change this to localhost as well. That's the domain that we are wanting to self-sign our certificate for. So common name localhost, subject alt name localhost. Let's save that off. These other things here, which maybe don't make a lot of sense, are basically just the features that we want our certificate to have. I'm not going to go into that here. So let's close that, and I'm being the paranoid person, and I'm just going to reopen it to make sure that it took the changes, and indeed it does. Okay. Perfect. So the next thing we want to do is go back to our WSL session or Ubuntu session. If we do a quick directory listing, we should see the HTTPS config file there. And so the first thing we want to do, and I'm just going to copy this command over, why ruin the habit of a lifetime, is create our private key. So OpenSSL, well, I'm not going to bother reading it out, but we basically read in our config file, and then we generate out this CSR, actually generate out a key.pem file. So we do a directory listing, we get a key pem file and the CSR pem file as well, and the key pem file is the one that we want. Okay, and then the last command that we need to run actually generates our certificate, and it takes in the CSR pem file, and then it signs out this HTTPS CRT certificate. Okay, there we go. So we do a quick listing, and these are the two files we need, this key pem file and this HTTPS CRT file. These are the two files that Envoy needs to read in and then basically use HTTPS. Cool. Now, come back over here, we'll do a bit of a refresh at F5. We have these files, so HTTPS, CRT, and key pem. I'm going to copy these. Now, just in the interests of, we could put them in with our other certificates, but I'm just going to not do that because I feel that they are ASP.NET certificates, so I don't really want to mix them up. So I'm just going to put them in the root of our Envoy folder. So it makes it a bit easier to define the paths to read them in, but you can put them anywhere really that you want that makes sense to you. So I think we're done with that. Let's come into here and we can see we have these files now. Fantastic. So the next thing we want to do is we want to basically read those files in via Docker Compose. So we're in Docker Compose now, and we need to add a couple of new volumes to our Envoy gateway service. And again, I'm going to copy these in from some config I have at the side for a different project to make sure I have the right folder name here. So we're coming in from Docker Compose, we're going into the Envoy folder here, and then we're grabbing HTTPS CRT, which is here, and then we're grabbing key.pem, which is here, and then we are just mapping them into these locations within our Envoy container. So don't forget to save that off. Now, what we will do while we are here as well, we'll just add our HTTPS port, which is 10,001 to 10,001, so we don't have to come back in and do that separately. Okay. Now you can see here, there's nothing that denotes that that's a HTTPS port. We do that in the Envoy.yaml file. And then, talking of Envoy.yaml, in order to ingest these certificates, we need to do that from within here. So let's do that next. Okay, so we want to move over to our Envoy.yaml file now, and we want to add in our HTTPS listener that uses the certificates the certificate that we just created in the last step. So going back here, we have our listeners section under static resources, and we have this existing listener listening on port 10,000 called listener 0, And you can see again, denoted by the little minus sign, that this is an array element. So I'm just going to copy this, and we're going to copy that config down to here. And I think I've put it in the right place, but let me just double check it's got to be aligned under here. Yep, that looks like it's in the right place. Cool. All right, so let's just, before we do anything else, save that. And let's just rename it as listener 1. Yep. And we'll come down here and we'll give it a port of 10,001. And everything else we're going to keep exactly the same. Even the routing for the moment, we're going to keep the same. It's just going to look for exactly the same patterns and route off to the API endpoints using our existing clusters on port 80, so HTTP. All right, so coming back up here, but the one thing we do have to add in to this new listener, listener 1, is we need to add in the paths to our 2 files. Now, I hope you don't mind, but I am going to copy that in again. And I just need to make sure I put it under the name of this listener. Oh my goodness, it gets really difficult to see. You need to put it under this element here. I really dislike YAML. I think it's supposed to be here. Let me just see. TLS context under the name. Yes. That looks correct. All right. Now, basically all this is doing, as you can see here, we're defining a TLS certificate section. First thing we need to provide is the certificate chain, which is this CRT file. And then we need to provide the private key, which is in the PEM file. So let's save that off. Now, just coming back to our PowerPoint, just to kind of go through what we're trying to achieve here. Okay, in case you've lost the plot, we're going to make a client request, this time to Envoy using HTTPS on port 10,001 with our new certificate. Now, we do actually have to do one more thing in order to trust this certificate, and I'll take you through that in a second. And then what's going to happen, we're going to use our existing routing to HTTP port 80 using our existing cluster to our T API. Now, remember, we've taken out HTTPS redirection. So this is effectively TLS termination. We're making a HTTPS request to our gateway, and it's just going to route to our API using HTTP, which I don't like, but this is a use case we're going through. And then the last thing in the video we'll do is we'll actually create a new cluster that you'll use HTTPS. But before we do any of that, we do have to come back and do one last thing. But before we do it, I'm going to just demonstrate what is not going to work properly. So everything's saved. I think it's time to do a Docker. I'll actually just do a listing to make sure we're in the right place. Yep, so you can see your Docker compose file. Docker compose up, -- build. Now I'll just rebuild everything, as you're probably quite familiar with now, but it shouldn't take too long. And what I'm going to do, yeah, that's okay. Let me kill that for the moment. Okay, so everything hopefully should be green. Refresh it. Yep, everything's green. So let's open up Edge. And we're going to go to HTTPS localhost, and we're going this time to our port 10,001, but we're still going to try and retrieve our T API. So what you can see here is we're getting this error. We're using HTTPS, but we're getting this, your connection is not secure. Now, the reason for that is that we haven't done one final thing, and you might be going, what haven't we done? What we haven't done is we haven't added our new certificate to our trusted routes in Windows here in this instance. So back into Cert Manager, and I know you'll probably still have questions, but let me just do this first. So over here, in Trusted Root Certification Authorities, we come down here, you'll go, well, hang on, we already have a local host certificate. Why isn't it trusting it? Great question. This localhost certificate was created by .NET Dev Certs, and you can see here, you know, ASP.NET Core, blah, 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 as the friendly name. That's cool, but the localhost certificate we created was done in OpenSSL. So it's a completely different certificate, really. Now, if you wanted to get everything using the same certificate, you can do that. You can then use OpenSSL to create a PFX file that we could then re-import here, and then get everything else, all our .NET Core stuff to use. I'm not going to do that. I just didn't feel it would add that much value. So we're going to import a second localhost self-signed certificate that we created with OpenSSL into here, okay? So very simple to do, all tasks, import, next, and we browse to where we need to find it. So just to take you a step back into my season 3 directory, episode 6, into Envoy, and then we have our HTTPS CRT certificate. There we go, open that in, next, make sure trusted root certification authorities is checked, next, finish that off, and you always get a warning. We'll say yes to that. Import was successful. Let's come down here. We'll just do a quick refresh, although I can see it there. Let's refresh it here. So you can see now we have 2 localhost certificate. This one here with its friendly name, excuse me, is for our .NET Core stuff. This one here is for Envoy. Okay. Now what should happen, I'm going to kill this. Well, let's try it again, but I think we'll still get a not secure because the browser needs to be closed down and refreshed, I think. I might be pleasantly surprised. No. Get the same thing, so let's kill that. Let's refresh it. And when it opens, it will hopefully get our newly self-signed certificate. So HTTPS localhost 10,001/T. There we go, fantastic. So we've still gone to our T API, but to all intents and purposes, it looks like we're using HTTPS, but when in fact we know that when we've got the data from a T API, it's not redirecting to HTTPS, we're just getting over a HTTP connection. So that's us kind of proved out this use case here. Okay, so HTTPS termination. Now let's just take a look and see what happens when we go to our Coffee API. You can see, yes, it does go to our Coffee API, but interestingly, if you go back here, when we called our T API via Envoy, and we got Earl Grey back, it retained the view that it's going through Envoy. When we go to our Coffee API, it doesn't. It still retrieves it, brings it back, but the URL changes to the actual native HTTPS endpoint for our Coffee API. Why is that? It's because of this HTTPS redirection thing, and it's because when we go into Envoy.yaml, we're hitting this listener endpoint, 10,001. We're hitting this route here. We're going down to Coffee service, yep, and we're hitting the Coffee API on port 80, and it's then redirecting. Now, because we don't have a secure HTTPS or TLS connection from our Envoy cluster, that's why we get that. Now, if we add in a new cluster that uses port 443, let's see what we get. Is we won't get this kind of redirected URL. It will look similar to this, okay, because Envoy is dealing with it within its config. All right, so let's do that now. All right, so what we want to do now, and the last thing we're going to do in this video, because my voice is about to give in, let's do Control-C to kill our running containers, and back over in our beloved Envoy.yaml file, you want to add a new cluster. So under clusters, we have Coffee service, which is going to port 80. We have T service, which is going to port 80. What we want to do is we want to add effectively a secure cluster for our Coffee endpoint. We could add one for T, but we're just going to do Coffee, and you can add a second one at your own leisure. So in a similar way that we did with our listeners and stuff, and also with our clusters, we're going to copy this entire cluster config. Control-C, and then I'm going to put it under here. And I'm going to call this secure Coffee service. And we're going to keep pretty much everything the same, apart from this. I'm going to copy this, paste that in. Oops. Okay, and down here, we're still going to go to Coffee API, but this time, coming back to our Docker Compose file, if we go down to Coffee API, we're going to map to port 443 this time. Now we have one more thing to do. Now you'll remember that, well, you probably don't remember now, but when we copied in the original config from the GitHub site, there was a section for the transport socket. So we just need to add that back in here because we're using HTTPS or we're using TLS. So I'm just going to copy that over. And I need to paste that under load assignment. I need to paste that here. Okay. Horrible, isn't it? All right, so transport socket, give it a name. We've got another one of these types, so you can see here it's using TLS version 3. And it then uses this SNI, and it's specifying the local host, which is effectively the domain that it wants to use. Cool. So I think that should be it. No, actually, it's not enough. We have one more thing to do. We need to come up to our secure listener. And then what we're going to do, if it's listening on HTTPS as a listener, and we get a T flag, or not a T flag, a coffee flag, rather than going to the coffee service, we're going to go to the secure coffee service. So we'll come back up here and go to this cluster instead. Cool. All right, so hopefully that made sense. Let's see if the diagram makes sense if we go and have a look at it on here. Hopefully you're following along. You're not falling asleep yet. So what we're going to do is we're going to do client HTTPS to port 10,001. It's going to go to Envoy. We're going to have the T route effectively, not the T, the C route for coffee. Forget that for the moment, and then it's going to use HTTPS to go to port 443. All right. So I think that's us. The YAML file is saved. Let's give it another go. So Docker Compose up build to build and see how we go. All right, everything's up and running. Yeah, looks okay, fantastic. So we're gonna go here. And just to remind you what happened last time, when we hit the 10,001 endpoint via Envoy, it did take us there, but it then redirected to our native coffee endpoint. We're going to change that now, or try something different now and go to C endpoint. And indeed, it does bring it back, but this time it doesn't redirect because we're using a HTTPS-based cluster. All right, I think we are done. So it's time for some final thoughts. All right, so once again, we reached the end of another quite long video. I hope you enjoyed it, and I hope you learned what you wanted to learn. So in terms of my final thoughts, I've got a few things bubbling around in my mind. A couple of things for me on Envoy. It's a huge area, so we only scratched the surface of it today, but hopefully what we did do today provides you with a nice launchpad or baseline in which to take your own projects forward. For me, the other couple of things I'll mention, I would maybe want to explore another video where we adopt the sidecar pattern for Envoy and use it to build out a kind of service mesh. So that's something I will think about maybe doing in the future. The other thing I will say is, for me, the documentation on Envoy is not that great. It's weird. It's a weird scenario for me, the documentation on Envoy. It's documented. There's a lot of documentation there, but I don't know if it's just me, but I just find it really circular, or I can't kind of find out what I want to find out. I find it quite frustrating. So maybe it is just me, but I'd be interested in your thoughts on the Envoy documentation as well. Other than that, my whinge is over. It's a great product, and I'm sure we'll be using and seeing more of it in the future. So for now, thank you again for watching. If you liked the video, give it a like. If you've not done so already, think about subscribing and you'll be notified of all the new stuff I put up. If you don't want to do that, that's fine. I'm just really glad you watched the video. That's what means the most to me, so thank you. And finally, to my Patreon supporters, as usual, your names are coming up now. But until I see you next time, take care and stay safe.